The question we are solving now belongs to test series 6. It is of network theory subject. In specific, it belongs to DC network solution methodology. The question is number 23. As per this question, there is a DC circuit given which contains only one independent source and no dependent sources. We need to find the Norton equivalent of the circuit as seen from the terminals A and B. From the given circuit, we see that the circuit contains only independent sources. So the Norton's current IN is given as the short circuit current between the terminals A and B, and Norton's resistance Rn is given as the resistance Rab as seen from terminals A and B when the sources are replaced by corresponding internal resistances. First, we will find the Norton's current. For this, we have to short the terminals A and B and find the short circuit current between terminals A and B. Once we short the terminals A and B, the equivalent circuit is as shown. So in this case, the 10 ohms resistor is shorted. So the current emitted by the 5-volt source Is is given as the 5 divided by 20 plus 10, which is 30. That is further can be simplified as 1 by 6 ampere. Therefore, the Norton's current IN is given as 1 by 6 multiplied by 1 by 2, because the current emitted by the source is 1 by 6 ampere, as this 10 ohms resistor is shorted and the resistances in both the arms are equal to 20 ohms. So the current is split equally between both the arms as 1 by 12 ampere and 1 by 12 ampere. Therefore, the short circuit current as shown can be obtained as 1 by 12 ampere. This is same as Norton's current. Now for finding the Norton's resistance, the equivalent circuit can be drawn as shown. In this case, the voltage source should be replaced by short. So in this case, the Norton's resistance Rn can be written as Rab. Here we see that the 20 ohm resistors marked are in parallel. So the net resistance is 10 ohms, which is in series with the 20 ohm resistor that is marked. So the net resistance becomes 10 in parallel with 20 plus 10, which is 30. So on simplification, this becomes 300 by 40. That can further be written as 15 by 2 ohms. So the Norton equivalent of the circuit can be drawn as shown. Here the Norton's current is 1 by 12 ampere and the Norton's resistance is 15 by 2 ohms. From the Norton's equivalent circuit that we obtained, we see that the correct option is A.